Hello everyone. Am I audible? Rahman, Mazi, Alvia. Do you have any doubts from the last class? No. All right. In the last class we did limits, substandard formula, right? The first formula we saw was limit extending to a x raised to the power n minus a raised to the power n upon x minus a is equals to n into a raised to the power n minus 1. This was the first formula. Write down the second formula, limit extending to 0 sin x upon x is 1. All right. If you have any angle, sin x upon x means you can change this to any angle. Limit extending to 0 sin 5x upon 5x is also 1. Whatever angle is written inside sine, if you divide by that same angle, the limit becomes 1. All right, write down this formula.
Sir, it should be only of sine.
Sorry.
Sir, it must be only sine x by x. It can't be cos x by x.
No, I'll tell you what happens when we have cos x by x. All right. This is also equal for tan x by x. Cos x by x is not 1. All right. If you put x equals to 0, then tan x upon x is also 1. All right. It's different for other formulas, and the inverse is also true. If you have, you can write down limit extending to 0 xy sin x. This is also 1. All right. And same for this. For cos x, what happens? Limit extending to 0 cos x only becomes 1, right? If you put x equals to 0, cos 0 is 1. All right. What more formula you can get? For cos x, there is another formula limit, but this is not that important for NCERT. 1 minus cos x on x square becomes half. All right. Limit extending to 0 e raised to the power x becomes 1. Limit extending to 0 e raised to the power x minus 1 upon x becomes 1. And you can replace x with any quantity here. All right.
Sir,
The
what
answer
does
will
E
be
stand for?
is the Euler number, if you know, 2.71. That is a constant. All right. If you remember or know about this log, if you have base e, we call that natural log. All right. That is a constant value. And here you can change the value of x to anything. All right. The answer will be same. Solve this question. Sin 3x upon x. What will be the answer to this question? Raman, you can use the formula directly here. All right. How we can use that? See, in the formula, you want sine x upon x, right? Whatever written in angle should be divided by the same number, right? So if you want to apply the formula, then we need to have 3x in the division, but we have x, so I can multiply 3 in the denominator and numerator, right? So this becomes the standard formula, sine of some angle divided by the same angle. All right, so this limit becomes 1. So
So
the
sir, it's 3.
answer is 3, right?
Sir, can you explain the part where you multiplied by 3?
All right, see, in the standard formula we have limit x tending to 0 sine x upon x, and I told you here this angle can be anything. All right, this can be 5x, 10x, some other angle, x plus 2, anything. But whatever written in this angle, that same number should be divided in sine also. So in here we have the angle 3x. So we need 3x in the division, but we had only x. So to make that x 3x, I have to multiply 3. So I can multiply 3 here and here. So that I don't change the quotient, right? If you ever divide by 3, you have to multiply by 3 also. So this becomes 1 and the answer becomes 3. All right. Okay. Let's try another question. Limit x tending to 0 sine of 5x upon 2x. Try to solve this one. Got the answer, Rahman? Mazia, Alvia? See, we can do the same thing here. Limit x tending to 0. We have sine 5x, right? So we need 5x here, but we have 2x. So I can write this 1 upon 2 into 5x. Because I multiplied 5 here, so I have to multiply 1 here also, right? So this sine 5x upon 5x becomes 1. So the answer becomes 5 by 2. Is it clear? All right. Another question. You multiply it with 2 by 5, but you get the same answer, right? We had sine 5x upon 2x. No, Rahman, see, you just cannot multiply a random number in a question, right? Because if you just multiply 5 by 2, then this question is changed. But if I multiply 1 5 here, another here, so I didn't change the question, right? That is very important. You cannot change the question. So whatever you multiply, you have to divide by that number also. All right. Look at it like this. Suppose you had 1 upon 2x here. Whatever number you want in here, 5x, to get the formula. So multiply by 5x in here also. If you divide, then you multiply also. So this x and x is cancelled. This becomes 1. The answer is 5 by 2. All right. Whatever number you multiply, you have to divide by that number also. Let's try another question. Limit x tending to 0, sine ex upon sine bx. All right. All right. So in this question, what we can do? Remember the question we solved in the last class? See, to solve this, we have to get ax in the denominator. So I divided by ax and multiplied by ax. All right. So that the question is unchanged. Whole divided by I have sine bx. I need bx here. So I divided by bx and multiplied by bx. All right. So this becomes 1. This becomes 1. X and x is cancelled. So the answer is a upon b. All right. This is clear, Rahman, Mazia Albia. All right. Another question.
Sir, can you explain the above question once again?
Rahman, do you remember in the last class we solved similar
Sir,
type of question?
the one above this one.
Above this one. All right. What we had sine 5x upon 2x, right?
Yes, sir.
All right. See, forget everything. Just look at this. If you have to use the formula, then you need 5x here. So I divided by 5x. Because I divided by 5x, I have to multiply by 5x also, right? And we had 2x in the division in the question itself. Is this step clear?
Sir, can we do the by the same method, like we can whole divide by 2x and like that?
You can do the same thing, right? But whatever you multiply, you have to divide by that number also. All right. If you want to multiply 5 here, you have to multiply 5 here also. That you have to remember. All right.
Yes.
All right. Let's try another question. Limit x tending to pi sine pi minus x upon pi into pi minus x. Rahman, have you solved this? You need to look out for one thing in this question. Here we have x tending to pi. In the formula, we had x tending to 0, right? So we cannot use the formula directly. All right, so two ways you can solve this. You can change the limit by, see, if x is tending to pi, then x minus pi will be approaching 0, right? If x is approaching pi, then x minus pi will be approaching to 0. So I can write the limit as x minus pi approaching 0. Now the question is, in the standard format, sine of some angle upon that angle, and that angle is tending towards 0. So this will become 1. So the answer is 1 upon pi. Right, this is one method to solve. Another method you can use is, you can take pi minus x as t. All right, pi minus x you can take t. So the question you can change this limit sine t upon pi t. In the limit, if x is approaching pi, then t will be approaching 0. So the question is change in another variable in the standard format. So the answer will be 1 upon pi. All right, you can use any of the methods, get the same answer. All right. Okay, let's try another question. Limit x tending to 0, cos x upon pi minus x. Rahman, you need to put the value of x in the denominator also, right? Direct substitution method. Just put x equals to 0. Right? All the questions should be starting by this only. Put x equals to 0. So cos 0 is 1 upon pi minus 0. So 1 upon pi is the answer. You don't have to do anything else in this question. All right. So you might get questions like this also, where you have to use direct substitution. Next question. Limit x tending to 0 cos 2x minus 1 upon cos x minus 1. Try to solve this one. Rahman, how did you solve this? Two sin x cos x, but we have cos 2x, right? Not sin 2x. Sin 2x is 2 sin x cos x. Here we have cos 2x. All right, look at the formulas. You can use the formula directly here also. This one, 1 minus cos x upon x square is half, right? 1 minus x, 1 minus cos x upon x square is half. In this question, we need this formula, right? So to change this into this, what we can do is limit x tending to 0. I can multiply a negative sign in numerator and denominator. First, I can write this as this. So one thing is clear here. 1 minus cos x I already got. Now again, what you can do, limit x tending to 0, 1 minus cos x. Now for me to use that formula here, I need to divide by this angle square, right? So 2x square, that means 4x square. But if I divide by 4x square, I need to multiply by 4x square also. Whole divided by, I have 1 minus cos x. Here also I need to divide by x square, multiply by x square. All right. So this x square and x square is cancelled. Now I can apply the formula directly. This becomes half and this becomes half. So ultimately what we have is half upon half into 4. So this is cancelled. The answer is 4. All right. This is one way to solve. Otherwise, what you can do is you can use the half angle formula. Limit x tending to 0, cos 2x minus 1 upon cos x minus 1. Now cos 2x I can write 1 minus 2 sine square x, and this minus 1 is already there. Cos x I can write 1 minus 2 sine square x by 2. This minus 1 is already there. So this 1 and 1 is cancelled. This is cancelled. Negative negative is cancelled. So ultimately what we have is limit x tending to 0. This 2 and 2 is also cancelled. So sine square x upon sine square x by 2. Again, same thing. To use that formula, to get sine x upon x, I have to divide by x. But here we have sine square x. So I need to divide by x square. But if I divide by x square, I need to multiply by x square also. In the denominator, we have sine square x by 2. So I need to divide by x by 2 whole square. Then I have to multiply it by x by 2 whole square also. So this becomes 1, this becomes 1, x square and x square is cancelled. This 2 square will be going upwards, the answer will be 4. Is this clear? This type of question will also come in the examinations. But you only need to know how to apply the formulas. All right. Note it down. All right, done. Now we are going to start derivatives. All right, so what are derivatives? You must have studied this in physics also. So what is derivative? Suppose I give you an equation y equals to x square plus 2. All right, I want to know how much this y changes when I change the value of x by some very small quantity. All right, suppose I x equals to 1 first, I get y equals to 3. Now if I put x equals to 1.000001, so how much change is there in y? All right, and that ratio is called derivatives. That is all right. So to understand this graphically, suppose there is a graph. All right, this is x, and then this is x plus h, where h is a small positive quantity. All right, I change the value from x to x plus h. All right, and we had a function f of x. So the value of the function will change from, this will be f of x, and this will be f of x plus h, right? If you put x equals to 1, then we try to find f of 1. If you put x equals to 2, we try to find f of 2. So if you try to find x plus h, then we'll be writing this as f of x plus h. All right, and this is the value of y. Let's call it this x1, this is x2, this is y1, this is y2. All right, now if this is a triangle, this is a right angle triangle, then tan theta. All right, tan theta is the slope of a line. How to find slope? y2 minus y1 upon x2 minus x1. This we already studied in straight lines. All right, y2 minus y1 upon x2 minus x1. So what is y2? F of x plus h. What is y1? F of x. What is x2? X plus h. What is x1? X. So tan theta we can write f of x plus h minus f of x upon h. All right, this we can write in tan theta in this right angle triangle. Now what does it mean by derivative? Derivative is when we make this h very small. Very small means almost zero. All right, when this difference, the difference between x and x plus h is very small, the the second point is almost here. All right, almost right to x, then what happens is this line becomes tangent here. All right, so we get the slope of the tangent. Is that clear? Rahman, Mazi, Alvia. So what we will do here is put h tending to 0. All right, where in tan theta, so f of x plus h minus f of x upon h. This is the derivative. All right, or this is called first principle method. All right, derivative by first principle method. All right, note it down. All right, write down few definitions. A derivative is defined as the rate of change of function or quantity with respect to others. Suppose f is a real values function defined by limit h tending to 0 then derivative is defined by limit h tending to 0 f of x plus h minus f of upon h. All right, it is denoted by f dash x. Note it down. This definition of derivative is also called the differentiation on first principle or by AP initio or by delta method. Thus, f dash x is limit s tending to 0 f of x plus h minus f of x upon h. X is also denoted by d by dx of f of x, or if y equals to f of x, then dy by dx. Derivative of f at x equals to a is denoted by f dash a or x equals to a. All right, note it down. This is or by AB initio. All right, AB initio. All right. We'll be sending you the notes. All right. Don't worry. Whatever the class lectures, class questions, all this one note, you will get the presentation. All right. Don't worry. You just test Niskas sir about this. He'll be sending you the note. All right. All right. So this is what derivation is using first principle. So if they give you a question, differentiate f of x equals to x raised to the power n using first principle. Method. All right. So what is first principle? That you have to remember, that is limit h tending to 0 f of x plus h minus f of x whole divided by h. That is all. This you have to remember, then solve the limits only. So first try to find this f of x plus h. So how we can find f of x plus h? Just put this value in the function. So what you will get? X plus h whole raised to the power n. And what is f of x? That is x raised to the power n. Substituting this value in this equation, limit h tending to 0, f of x plus h whole raised to the power n minus x raised to the power n whole divided by h. All right. Now this looks like the first formula, first standard limits. something raised to the power n minus something raised to the n and similar. But here the limit is also not the same and we don't have the division. So what we can do is put x plus h, another variable t. All right, so the question will become limit x plus h is t, so this is t raised to the power n, and x will become t minus h, and this will become h will become x minus t, right? Or don't change this one, just write it as x raised to the power n, and this is x minus t. All right, now you can change that standard limit, apply the formula, right, Rahman? Is this clear what I did here? First principle. All right, so this way you can calculate. So the formula will be n into x raised to the power n minus 1. All right, okay, solve one question. F of x equals to sin x. So derivative, find derivative using first principle. Rahman, yes, you know directly, but they may ask you to derive the formula for that. All right, they may ask you to try to find the derivative using first principle. So you should be able to solve this one also. All right, this is the part of the syllabus. So try to solve this one. Solve this, Rahman. Alright, how do you differentiate using first principle? What is first principle? F of x plus h minus f of x all divided by h, limit h tending to 0. So what is f of x plus h here? That is sine x plus h. What is f of x? Sine x. Substituting these values, limit h tending to 0, sine x plus h minus sine x upon h. Alright, now you can use the formula for sine c minus sine d. So sine c minus sine d is 2 cos a plus b. So cos a, c plus d is x plus h plus h. So x plus 2x plus h into sine c minus d, or by 2 also, by 2. So c minus d, so this is h by 2 whole divided by h. So now if you put h equals to 0 here, this becomes cos x. So no worries there, but this becomes 0 by 0. So now to get the standard formula, what we can do is divide by h 2 multiply by 2. So this becomes 1 now. This 2 and 2 is cancelled. All right. Now put the value of h as 0. So if you put h 0, then 2x upon 2 is only x. So the answer is cos x. This is how we know that the derivative of sin x is cos x. All right. This is called first principle. Very important. All right. Note it down. All right, Aman. See, what we got here is 2 limit h tending to 0 to cos of 2x plus h by 2 sine of h by 2 whole divided by h. All right. Now, whenever we are trying to solve limit, first put the value of h as 0. Put the value of h 0. So this is 2, no issue. 2x plus 0 by 2 cos x, no issue. Sine 0 is 0. And here 0 is 0. So the answer is 0 by 0. We don't want that. So how we can solve? We know sine x upon x is 1. And here the angle is h by 2. So to get h by 2, I can divide this denominator by 2 and multiply 2 here, right? This 2 and 2 is cancelled, so no issues. Now this limit h tending to 0, this becomes, see, this 2 and 2 now I can cancel. This becomes cos 2x plus h by 2 and sine of h by 2 upon h by 2, right? Now, according to the standard limit, sine of some angle divided by that angle is 1. So we can directly put the limit. So put h equals to 0 in here because this is 1. If you put h equals to 0 here, so 2x plus 0 by 2x, so that is cos x. All right. Note it down. And also some questions for you to solve at home using first principle. F of x equals to e raised to the power x. F of x equals to log x. F of x equals to cos x and tan x. Let's solve all these questions using first principles. All right. And if you have any doubts in this type of question, ask me in the next class. Today we are moving forward. I hope this first principle is clear to you all. Note down the questions and this answer. All right, this was first principle. Now there is another definition of derivative. You can write definition 2. Suppose f is a real valued function and a is a point in its domain. The derivative of f at a is defined by limit h tending to 0 f of a plus h minus f of a upon h, provided this limit exists. Derivative of f of x at a is denoted by f dash. Now let's note it down. Now let's suppose they give you a question. Find the derivative of f of x equals to sine x at x equals to 0. Already using first principle. What you can do is limit h tending to 0. This is f of a plus h minus f of a whole divided by h, where a is 0 here. So what we can write here is limit h tending to 0, f of 0 plus h minus f of 0 upon h. Substitute the value here, limit h tending to 0. So putting the value of 0 plus h in sign, so this is sin 0 plus h is sin h, sin 0 is 0 upon h. So sin h upon h is 1. This is the answer. Note it down. This is clear, right? I hope everyone clear about this. All right, solve one question. Find the derivative of f of x equals to x square plus 1 at x equals to 2. Ramon, you only have to find the value, right? Value of the derivative. How you can solve this? Limit h tending to 0, f of 2 plus h minus f of 2 whole divided by h. So this is equals to limit h tending to 0. So putting 2 plus h in the function, so 2 plus h whole square plus 1 minus 2 square plus 1 whole divided by h. The bracket here. So limit h tending to 0, opening the bracket 2 square plus h square plus 4h plus 1 minus 5 whole divided by h. So this is cancelled. Now you can divide by h. Limit h tending to 0. This is h plus 4. Now put the value of h here. So the answer is 4. All right, very easy. So this is for first principle. All right, now we have already found a few formulas using first principles that you only need to remember. All right, unless they tell you to use solve the question using first principle, you can use the formula directly. Formulas for differentiation. All right, differentiation of x raised to the power n will be n x raised to the power n minus 1. What this means is, if you have to differentiate x raised to the power 4, and this will be, here the value of n is 4, so 4 into x raised to the power 4 minus 1, 4x cube. All right, differentiation of sine x. Differentiation of sine x is cos x. Differentiation of cos x minus sine x. Differentiation of tan x, sec square x. Differentiation of cot x is minus cosec square x. Differentiation of secant x is sec x into tan x. Differentiation of cosec x is minus cosec x into cos x. Differentiation of e raised to the power x is e raised to the power x itself. Differentiation of e raised to the power x. What is the difference between e and a? E has a specific value where e is 2.71. Whenever you see e, that means this value. But a can be any constant to the power x. If you have to differentiate, and this becomes a raised to the power x log a. All right. If you have to differentiate logarithmic functions log x, this becomes 1 upon x. This is base e. If you have differentiation of log x base a, then this is 1 upon x log a base e. And this, all this formula you have to memorize. There is no other way around this. You have to memorize all this formula. Write it down. All right, let's solve few questions. Differentiate the following with respect to x. X square plus sin x plus 1 upon x square. How we can differentiate? See, differentiation, you can break this into three differentiation. The question is differentiate this whole function. So what you can do is break this into three parts. So this is dx square upon dx plus d sin x upon dx plus d1 upon x square upon dx. All right, you can find the differentiation individually if they are added or subtracted, not otherwise. All right, so here you can use the formula for x raised to the power n. So that becomes 2 x raised to the power 2 minus 1 plus differentiation of sin x is cos x. All right, differentiation of sin x is cos x plus how we can find the differentiation of this. This we can write x raised to the power minus 2. Right, differentiation of x raised to the power minus 2. So this is 2x plus cos x. In here the power is minus 2. So minus 2 x minus 2 minus 1. N into x raised to the power minus n minus 1. So this becomes 2x plus cos x minus 2x cube. All right, clear? All right, next question. You guys solve that. Ax square plus bx plus c whole divided by under root x. Solve this one. I'll give you a few minutes. Rahman, root x you can write x raised to the power 1 upon 2 and use the same formula. All right. See, in this case, you cannot solve directly. All right, you cannot solve this differentiation directly. So what you can do is you can break this function like this: ax square upon under root x plus bx upon under root x plus c upon under root x. Now write all this in x to the power something, then you can differentiate very easily. All right, now differentiate this function. Rahman, because here the two functions have been in division, right? We don't know how to differentiate two functions when divided. The formulas I gave you should be applied directly only. All right. See, if you have x raised to the power 5, this we can differentiate. But if I write x raised to the power 5 upon sine x, then you cannot do this upon this, differentiation of this upon different. No, that is not workable. All right. So you have to break this. Now what I can write is a x raised to the power 2 minus half plus b x raised to the power 1 minus half plus c x raised to the power minus half, because under root is half. If it goes in the numerator, then the power is changed. So this is a x raised to the power 3 upon 2 plus b x raised to the power 1 upon 2 plus c x raised to the power minus half. Now you can differentiate using the standard formula. So this is a, n is 3 by 2, x raised to the power 3 by 2 minus 1 plus b into n into x raised to the power 1 by 2 minus 1 plus c into minus 1 by 2 into x to the power minus 1 by 2 minus 1. So this is 3a by 2 x raised to the power half plus b by 2 x raised to the power minus half minus c by 2 x raised to the minus 3 by 2. So this is 3a by 2 root x plus b by 2 root x minus c by 2 x raised to the power 3 by 2. All right. Don't try to solve this differentiation directly. Make it as simple as it is using the standard formulas. Try next question. Under root x plus under root x whole square, under root x plus 1 upon under root x whole square. All right, how to differentiate that? Just open the brackets. So this will be under root x whole square plus 1 upon under root x whole square plus 2 into root x into upon root x. So this is cancelled. So this is x plus 1 upon x plus 2. Right? Now you can solve that easily. All right, 2 you can write x raised to 2 into x raised to the power 0, or you can remember that differentiation of any constant is 0. All right, d by dx of any constant k is 0. So this is x raised to the power 1. So differentiation of that is 1. All right, n into n minus 1 you can calculate, plus this is x raised to the power minus 1. So this is minus 1 into x raised to the power minus 2 plus 0. So this is 1 minus 1 upon x squared. All right, let's solve one more question. X square minus 3x plus 2 into x plus 2. Try to solve this one. Yes, Rahman, you can use the product rule, but you don't have to use product rule here. You can easily multiply, right? So x cube plus 2x square minus 3x square minus 6x plus 2x plus 4. If you multiply this, so this is x cube minus x square minus 4x plus 4. Now differentiate. So this is x raised to the power 3. So 3 into x raised to the power 3 minus 1 minus 2 into x raised to the power 2 minus 1 minus 4 into x raised to the power 1 minus 1 plus 0. right? Differentiation of any constant is 0. So this is 3x square minus 2x minus 4. All right, this will be your answer. All right, Rahman, this is clear. All right, this is all for today's class. All right, in the next class we're going to finish this chapter and your syllabus also. No, you don't have to differentiate again. All right, Rahman, you only have to differentiate this once, right? They ask you to differentiate, so you can only differentiate one time. If they ask you to differentiate again, then you can differentiate. All right, these 3 lines, I just simplified this question. I didn't differentiate. I only differentiated in this part, and then I simplified. All right, if they ask you to differentiate, only differentiate once. All right, in the next class we'll be solving using product rule and quotient rule and everything. All right, till then solve NCRT, whole NCRT limits and derivative. Don't touch derivative for now, just solve limits. All right, and all the questions that I gave you using first principle, and ask me if you have any doubts in the next class. All right, this is all for today's class. Take care.